And so welcome everybody to the Propeller Live Forum. Just hit the record button. So today we are hearing from Ada, also known as Würfel 21 from the Parallax forums.
It's called, sorry, I just had to laugh. It's called 21. It's 21. There's a big difference there. I know someone who's from Poland, and she always says ein instead of eins when counting.
Also, mein Deutsch ist verschleckt geworden. Okay, so today...
She has the stereotypical American accent.
Good. You're showing us the NeoYume game emulator you've made, the hardware, and some games that go with it. So before you start, and we have a lot of signups, by the way, and also a lot of people here today, which is great. Can I do sideways and let Chip show his debugger process?
Oh, yes, I want to see that.
Okay, so we'll do that. And then first, before Chip goes, I noticed that Eric Smith today released a new flex prop. Okay, so that's
that's good there. Because the emulator needs it.
That's good. Actually, I thought, Ada. So
actually, doesn't it need 11? Actually, it might actually work with the previous version. I don't even remember.
Well, it should work with 12.
Yeah, it should work with 12, definitely. Let's just check. I've written it down in the README file.
And what are the big changes here, Eric, since you're with us?
It's mostly bug fixes. There are a few new features like a line input in BASIC, and some new C functions for accessing some of the built-in features of the chip. And a little bit better interface between C and Spin. So if a Spin 2 program is including C objects, works a little bit better, which I think is what Ada needed.
Yeah, I needed like a couple extra library functions. Forget what they were. One thing that's always bugging me is I think what was it? I think read there. Yeah, that returns like a struct, and you can't really do that in Spin, so that always has to include a C file anyways, but it's really stupid to do it that way.
Okay, so I pasted the link in the forum chat if anybody wants to go download it, and be sure to make a deposit in his Patreon account. And then also while we listen to Chip and then get ready.
Ken, you have 92 unread messages.
Oh, how do you know that? Oh, yeah, I better take care of that. Okay, there is also a forum thread, which you may be interested in reading if you're into the emulating games and all that. So I just pasted that link in there.
And if you're interested in reading 30-page forum threads, I actually love reading old forum threads. So I think I've contributed to the old forum threads in 10 years. In 10 years, it's going to be an old forum thread that someone reads, and I don't know,
here you
derives happiness from.
And then also other information. Stephen Morocco, who's with us, has released some Spin 2 driver for this eInk Click ePaper bundle that we offer at Parallax. This is a really low cost eInk display, and it plugs onto the Johnny Mac board and the mini breakout board. So Stephen, maybe you could paste into the chat, okay, the link to your GitHub, and I'll put the link right now to the bundle. So with that being said, Chip, let's see what you got. And then maybe we'll do a quick walk through Stevens and then let Ada run wild.
All right.
Sound like a good plan?
Yep.
You okay with that, Ada?
I think probably.
Okay. All right. So all you, Chip.
All right. Let me set the screen up here. Okay. So let's see here. Let me get this. And here is this. Why is my picture here? Okay, so here's a little program, right? Can you see this? All it does is increment a variable and then do a break, which turns on the breakpoint debugger. So if we run this thing, let's see, I got to drag the window down in here. So we get this. I don't have the, I just got these buttons in yesterday, all these across the bottom. So I don't really have them, you know, modal yet. They're just kind of there responding to mouse over events. But anyway, the way this thing works is you can see everything at once. Well, not everything, but you have pretty much instantaneous access to everything going on in the chip. If you take all you have to do, you don't even have to click anything. If you just move the mouse around, you see this? This is the LUT, right? And this is the register memory. So this is the interpreter. So I modified the interpreter so that when you start it up, it clears out the unused areas so that you have a nice visual of that when you run the debugger. You can see, like, it's pretty obvious where the empty areas are that you can use. And then down here, there is a heat map that runs in this area. And by moving around, you can see just by moving, I'm changing addresses. So there's not much changing here, right? There's nothing changing at the moment because we're stalled. But anywhere you move in here, you can see the address changing on the left. If I just click it, then it makes it static. So I can go there. So it puts it here, you know, and also puts it up here. Whoops. If I go to like 0, the beginning of memory, I can just use the thumb wheel to kind of scroll around in here. But the way this thing works is it's like everything is instantly available, but it only fully buffers the cog memory and then whatever you're looking at in the hub and whatever these pointers are pointing to. But the debug interrupt, let me switch cameras real quick here to show you just for a sec here. Let's see. What do I do, Ken? Stop video?
Yep.
Stop
And choose
share?
a different source.
Oh, okay, yeah, let's see. Let me go to the, here we go. Let me get this other thing here. Okay, here we are. Oh, I can just drag this in. Do you see this?
Yep.
Okay, so you see this is 1 millisecond per division, right? So what happens is when a breakpoint occurs on the P2, that cog sends a message to the host, being the PC, and the message consists of checksums, actual 16-bit CRCs for every block of 16 registers inside the cog register and LUT space. So you can tell, so you keep track of this on the PC side. So you instantly know if anything changed. So it sends you a summary of the CRCs for the whole cog, and then it does some looser, easier to compute checksums on the entire hub memory. And that happens from, can you see my cursor? Do you see my cursor, Ken?
Yeah, we do.
Okay, so from this point on, it takes about 1 millisecond for it to do the initial preamble, and then I think from here to here, it's sending this, it's computing and sending the CRCs for the cog, and then the rest of this here is the checksums for the entire 512K hub. Computes it really quick, and then it sends off these checksums. So the PC keeps track of this stuff, so it knows where anything in the hub changed. Then up here, you see this top part, this is the PC sending back. So I went and I set the latency for my USB to serial port down to 1 millisecond. Otherwise, this thing would be stretching out to 16 because that's what it is by default. But I've set up this whole communication sequence so that there's only one latency period that you have to suffer. And you can see it's the PC responding to the initial barrage from the cog and the P2. And then very quickly, the P2 responds with data. So up here in this top part, what the PC says is, okay, I need some detail. I see that the CRCs have changed for these sections. So it actually sends like a bitmap of, I don't know, maybe 4 longs or something, so that and then the P2 goes and looks and go, oh, he wants this block, this block. So then it sends detailed information about what's in those cog registers. So the PC sends some like little bitmap here about what it needs information on, including updated checksums for any sub checksums. It does some very gross checksums on the hub memory at first, And then based on what gross checksums changed, it requests the fine granularity checksums. And then in this last little bit here, the P2 turns around and he sends everything like, okay, here's all the hub blocks or the cog blocks that you requested. Here's all the detailed checksums for the hub that you requested. And also here's all the read data that you requested, just because it needs like 5 random hub reads to get the pointer A, pointer B, the fast pointer, and some other stuff like where it's disassembling from. So this whole exchange, this is a whole breakpoint, right? It gets you complete updated status on the cog and the entire hub memory. And it takes like 1, 2, 3, 4 with this 1 millisecond latency. 5 milliseconds is like a whole exchange. So you can do like hundreds of these per, well, you know, pushing 200 of these per second. But which is, you're not going to want to do that many, but there are 8 cogs and there are other cogs that might want to have these little conversations with the host. So that constitutes the entire exchange for a breakpoint. And in here where the PC sends data, he's also sending like, okay, I want you to, you know, set the break condition to this and exit, or do a 64 millisecond wait and come back later and poll me again. Because really most of the time here, we're waiting for the user to press some button, right? So we broke right here. If you remember our little program, let's see, where did he go? Oh, no, I think he's behind this thing. Okay, there. Our little program is just a repeat loop with a breakpoint every time it loops, and then it increments this variable I, which is going to be a stack variable. So we can step here and see, and it's kind of funny to look at, because when I don't know if this is the best way to show skipping by putting lines through things. It actually looks very distracting. I think it might be better just to darken that font or something. This is a little crazy, but I'm just now to the point where I'm starting to use it. So that's going to make a bunch of other changes happen. But anyway, as I step, like, see, it's going to go to the call. It's going to skip the call because there's an alt instruction, and it's going to stop at the add instruction next. So the next is add 1D5. Then it's going to skip all that stuff, and then it's going to land on the alt, and it's going to skip the call, land on the return. Now it's going to return back. And because 1FF is on the stack, the X byte is ready to go. It's going to go get another bytecode then. So as we step here, we are just running through the interpreter that's running that code. And I could at any time go around and I could, like, you know, if I want to like stop and look at, say, this, I'll click and it kind of holds it there. But as soon as I like click back, it goes back to where the PC is when I click in here. But I could also go anywhere in the down here in the hub space, and I can scroll around, and because I'm there, it will disassemble what's there. So it lets you like see everything and disassemble everything. And then to get back to where the program counter is, you just click in here and it takes you back. Also, you could click on any one of these bytes within any of these, and it sets the hub, the expanded hub display to that address. And also, if you like want to make like this A3 first, you can go click on that. And then you can even like fine scroll by byte, which has a big effect on the disassembly, you see, as you change the byte offset around. Anyway, then I also have this walk thing that I just got working before the meeting. So there's no timer in it, and it just runs full blast. But so it's really crazy. It's doing like probably 160 breakpoints per second, and it's single stepping through that program. But you can see here on the heat map, you see that little glowing dot? If we go there, and I can click on it to lock it in. What, did I miss it? Let's see here. Hold on, it's kind of fine. There, okay, now I've locked it. So 1300 is the stack address that is the I variable in that little program. So it's single stepping, and you can see it incrementing what is the I variable on the stack. I can go up here. And And you can also see if I move over here, whoops, it shows you, if you look over in the cog and LUT, you can see where the execution is happening. It's highlighting the areas where the program counter or the disassembly window is. And then the stuff down here that's changing and turning bright, anytime anything changes in the cog, it brightens up and then fades back to normal. So it kind of draws your attention to where the changes are. And one thing I need to spend some time on is this little sub window down here. It's kind of going to use like a little cache algorithm to figure out where the changes are occurring in the register, maybe the LUT space, and then it will bring those to your attention. So if you're running some code that keeps incrementing some variable that's getting hit a lot, it'll show up in this list here with its value. And you can, if you can go to any of these, you can use this to set the address. Just click on it, or go back and see what the program counter sees. And then here it's showing you everything that's in the cog that's visible. It's displaying, but you can get quick access to the entire, hub memory through here, and you can see all the cog status within the rest of this pane. Any questions?
So let's take quick comments and questions for Chip, because we're definitely going to have a whole P2 forum on this at some point.
A quick question, Chip. I'm sorry, I'm a little out of date, but what's this program that we're seeing here on the PC? Is this Peanut or is it a standalone?
Oh yeah, it's Peanut right now, right? So this, I just made a new unit for the Delphi code, and it, runs this debug window. It's like about 2,000 lines long, and it makes all this happen. And you see, I didn't use any Windows controls here. It's all just mouse move events, mouse down, and thumb wheel events or mouse wheel events. That's all it does. And then it updates this bitmap in response. So it doesn't use any kind of standard Windows stuff. It's all kind of full custom. Does that make sense?
So are you thinking maybe of making this a standalone program at some point?
I haven't thought about it, but we could.
Seems like it would be pretty handy, like being able to debug assembly like this would be great for people who are using other languages like Catalina C or FlexSpin or.
Yeah, it's agnostic. It doesn't care what you're doing. I mean, it's not doing any kind of symbolic representation either. It's purely like, here's what the machine is doing.
Yeah, and it's really nice to have that.
The only limitation is you have to be able to compile in the debug statements, right?
That's right. And but let's see.
Mysteriously, FlexSpin can already do that.
Yeah, here's what I did.
Debug break, that still needs to be added, but
Yeah, just need to add that break special keyword.
Yeah, and I don't know. I mean, I could later overload this and give it some like conditions about how to operate, because maybe there's something you want to look at, especially. But
yeah, like break on a condition would be perhaps useful.
Yeah, the hardware limits us to like if you look at this thing here, we can whoops, hold on. We can have an address match. We can break on any of these interrupts, both the entry and the body code. And then this is the main code. And then we can also break on one of these events, meaning these things up here.
Right.
But not really like when this and this variable equals that, and this.
No, I mean just break if the flags are a certain setting.
Oh, you could make the break conditional. Yeah, you could do that.
It of course still takes cycles because of the funny non-bug where it doesn't accept the condition. But
actually, let's see here. Let's put it in, let's do a little conditional thing really quick. We'll go like if let's see, and 7 equals 0. So every 8th time through. Right?
I mean, Spin you can do that, but in assembly you can't without inserting like a jump instruction.
Yeah, you have to put a jump in. So if I run this thing now, oh, whoops.
Ah, the classic.
So now if we run this thing fast, and we go and look, it's only breaking now. Let's see. Why are we not seeing it was 13? Have some stuff out here. Oh, because I think we're just single stepping. So it broke on one of those. I need to add some other kind of button that says, okay, exit until we get like another external. I need to put a run button in.
Have you ever seen like an actual debugger? Because they have a run button. They have a button to step. They have a button. The run button just runs until the next break, and then they have a run until return, I think.
Yeah.
And also a step button that skips over any function calls.
Yeah.
Because we presume,
Step
you
into
know what the function's gonna do, so you don't want to see it.
Right. Yeah, I need to add those, and that would be using breakpoint address. That's how we could jump over that.
Chip, one thing on your display, you were talking about the lines were distracting. Just one opinion, but do you have an ability to make them a little bit darker and more transparent? Because I like the lines as the strike through idea.
Yeah, you mean just make them a little more transparent and darker?
Yeah.
Oh,
I had
yeah.
a thought similar to that, kind of go lighter as if it's grayed out.
Okay, that's easy to do. I just got to go down here in the, let's see.
And more
Here we go.
comments like that
Skipped
for Chip?
instruction. Here we go. So this is the, okay, we could do like only 25% opacity, right?
Right, right.
And then let's see what that looks like.
So Chip, I'm probably going to move you along just because there are a lot of people
Yeah.
here that want to see the emulator and gaming.
Yes.
If you
Yeah.
don't mind.
Okay, so anyway, no,
The
that's
gaming.
okay. So
That's
here's what
The
it-
gaming.
yeah, so I'll clean it. I'll be making this better. It's just now becoming usable. So this is going to bring about a whole bunch of other kinds of changes. All right, so that's, so I'll stop sharing now.
Chip, I put your email address in the chat so people could send you more comments too.
Oh
Okay.
no.
So yeah, send Chip your feedback so we can get the user interface functionality kind of the way you guys would like it. Okay, so one more thing, Ada, then we'll turn to you. Stephen, can you show us your GitHub for a moment?
Sure, I can do that.
And this is relevant because there's a lot of good Propeller 2 hardware. There's the brushless motor control, the eInk display, and the Raspberry Pi P2 gateway is all in here.
I have to move some things around. I'll be right.
And we try to draw attention to this in some of our newsletters and quick bites, but I'm sure we aren't reaching everybody. So just want y'all to know about this valuable repository.
All right, all set up. Now let's do this. I went to share and it wouldn't show me the region I wanted to share to you. All right. Let's see if this is working. Tell me if you're seeing it. Do you see a window dragging around? What do you see?
Yep, we see, it looks like a really neat futuristic city with some P2 hardware in the middle.
Good, okay, good. You found me. Okay, so what I'm doing is these are the 4 different displays supported by the Click module, and this is my development environment. Can you see my mouse okay?
Yep.
Okay, good. I'm going to formal displays like this so you can actually have text in the documentation. And so I'm just working that layout right now, but you can see that I'm able to place bitmaps, rotate them, and I can do white fonts, black fonts, rotated fonts, horizontal and vertical. And that's all in the driver and working already. This is what the repo looks like. And these images in the repo will be replaced with P2 driver images instead, rather than using micros. Of interest in the driver, this is the source utility for creating bitmaps. It's in the C source directory. And basically you visit a website, create the bitmaps you want, run the conversion utility, it walks you through it. And then it generates a spin file and you compile in your spin. Pretty easy. Very few modifications. Download the C source from the website after editing. Going back up, the other thing I'll show you is that the docks, there are individual hardware controllers on each of them, on the displays themselves. Here are the 3 sizes. You can see all 4 sizes here in my picture. These are the 3, and I'll put up the 4th one. I get that one working. The 4th one is an older model display and is theoretically capable of doing grayscale to 4 different colors: light gray, dark gray, black, and white. The other 3 that you see pictured here are only black and white, monochrome. And these are the hardware manuals for the displays. And that's really all I wanted to show you. That's what I'm working on. This is truthfully a Spin2 driver running SPI. And it is, there wasn't any need for PASM because the displays themselves take almost 20 seconds to refresh. So writing to the screen is nothing compared to the time it takes just to have the display refresh. I'll have videos and things up there. So the demos are in the, that stuff is available right now from this repository. And there's a related post. And if you have any issues with it, talk about it in the forums or post an issue. And here's your link to the forum as well. When you're looking for, you want to post something or contribute. So that's what I have.
Well, thank you very
Any
much.
question?
Oh, you can see those displays outside in the sunlight quite nicely, right?
Yes. What you saw on that image is you see them with the last display written to them, their e-paper, and so they retained that display beautifully, which is great fun for low speed status changes on your device. If you want to put out the latest status that's going to be long lived for half hour or something, it's not really for live displays of, you know, high velocity data, but they are fun to use.
Well, thanks a lot for putting together the quality docs and the GitHub and making it easy to find.
And Jacob was asking, do they hold their display without power? Yes. You can see the displays on my image completely disconnected from the hardware, still holding the display.
Yep, I've got one on my desk at work that's shown our logo for about 2 years now.
There you go. Yep.
So, okay, moving on then. Ada, bist du bei uns?
What?
Are you with us?
Yes, yes.
Okay.
You need to pin my video, otherwise it doesn't.
Okay.
OBS magic.
All right, let me take care of that in just a minute. So introducing you, your background in hobby retro computing, you describe yourself as a strange weeb with totally epic gamer goddess styles. So like a lot of our customers.
Oh God, he reads the stupid things I say out loud.
Well, we don't like to talk about ourselves, but it's important. We know who you are. And I think like many of our customers, you're a unique independent thinker. You installed a Tor browser on a company computer, which probably didn't go so well for you. But
yes, that was my only job. I installed Tor browser on a company computer and then I was fired.
If you've had, so you have the same number of professional jobs as Chip does. All right, so let's turn to you. Run wild, and thanks for being here today and sharing everything you've got. And how do you want to handle questions, comments as you go along? Do you want? I
have a question slide at the end.
Okay. And should I pin your display while you get going?
Yes, yes. Just, you have to. It's already ready. Everything is prepared.
It looks good.
Everything. Is it pinned for everyone?
I'm looking for the pin label, which may have moved on us.
Good question, because I could rant about LibreOffice being stupid for like 20 minutes after using it for once.
Okay, you're pinned.
Not on my end, but okay. I think. What would you need to do to that? Even how it should work, hopefully. If not, anyone can pin the thing by themselves, because it's just click on the little 3 dots. Anyways, I'll read out anything that says anyways, but then you won't get the funny pictures if you don't do it. or you'll get them in a very small size, or you'll get them in, I don't know. Anyways, let's do the thing, right? You see the intro slides, it's very funny. I said Chief Procrastination Officer at Irksome Software, non-incorporated, me. And I have a very high quality presentation on the new emulator thing, IDFK LMAO. So you may have seen the funny previous one. It was called, I say previous, it still exists. It didn't magically vanish off the face of the earth. It's probably more useful, but it's called NeoYume, and it's the Sega Mega Drive emulator for P2 and the RAM expansion. It's very cool. Runs most of the games. It runs them in real time. Like there's no delay, like you'd have on like a Raspberry Pi running like, I don't know, what would you run? MES maybe, Gen Plus under RetroArch. I don't know. It's the amazing reason that ShiftGIS was added to FlexSpin, which is very useful and not at all stupid. And it's not done. It's just in beta, but I haven't done anything to it like ages. So I guess it's finished, but not done, you know? I'd have to fix the bugs. And fixing bugs is stupid for Ruby people. Are you even seeing the thing? I hope you're seeing the thing.
We see the prior art, and then now you can.
Okay, well,
you only use 10%.
You only use 10% of your brain if you're P2 Edge 32 megabyte running NeoYume, that is. Because a normal Mega Drive game is somewhere between 128K and 4 megabytes. And, you know, I think, 3.2 megabytes would be 10%. Most of the games are less than that. So I guess it's even less than 10%. Brain empty. Technically just bank switching, but bank switch. Sega equals lame, question mark, question mark, question mark. It says that on the slide. So evidently we need something that's a bit more high energy, right? That's actually like using the thing. No, we don't, but I decided we do. So we have, of course, the next thought is NEO-GEO. Now what the shard is a NEO-GEO. It's basically when some dudes working at SNK and Alpha Denshi in 1990 were like, oh, what if we make an arcade machine that uses like cartridges like a game console? And they made the NEO-GEO MVS. And it was arcade machine with button. And then they decided, wait, we already have this hardware that takes cartridges like a game console. Why don't we make a game console? And they made the NEO-GEO AES. And then they realized, first they wanted to just rent it out, but then they realized people actually want to buy this for ludicrous amount of money. Like they got people calling them, where can I buy this? So they made it as a thing that you can buy. I think the US launch price is like $650, $1999, which I think it makes it the most expensive game console like ever, even if you like consider inflation. That's pretty epic, let's say. Very rich people thing. But I think that 650 includes like the second joystick. So, you know, you're getting your money's worth. But what do you get? Well, you get a 12 megahertz 68000 and a 4 megahertz Z80 with 64K and 2K RAM respectively. And that's of course why it's the next thought from Mega Drive, because that's the same dual CPU setup, just faster. And also they don't share memory in NEO-GEO. In a Mega Drive, they kind of share the memories around a bit. On this, they just talk through a mailbox. Then there's the YM2610 sound chip by Yamaha, which has a 3 square wave noise voices, like an AY389. I should stop trying to read the numbers. It makes my brain hurt. But it's a clone of the common square wave chip that you get. It's got 4 operator FM channels, same as the sort of all the other OPN type chips, YM2203, YM2608, YM2612. Once again, that's actually very similar to the Mega Drive. That has the same FM core, but with 6 channels and with like crunchy distortion on it. Then there's 6 ADPCM-A channels, which have a fixed frequency, about 18.5, and 1 ADPCM-B channel that you can actually adjust in pitch around. As someone on the forum noted, very rare to see these PCM things with adjusting pitch. But in this case, they get one, even with linear interpolation between the samples. And then, of course, the spicy part, which is the custom video ASICs, 320 by 224, you know, the usual resolution. But in this case, it's slightly wide, so a lot of games actually just don't render anything. They're like left and right most columns. There's 16-bit color, 384, it can be on the screen at once. I say that as if it's not much, but it's actually quite a lot. It's 256 palettes. Remember, Mega Drive had 4 palettes for everything. And here you get 256 of them, which is quite a lot more. In fact, 64 times more. In fact, significantly more, orders of magnitudes more. Okay, no, that joke was bad. You get 380 of these, what they call 3D line sprites, that you can move around the screen. They are 96, you can handle 96 per scan line. And they're basically like a vertical slice out of a tile map. So you get your one column of 16 by 16 tiles that just goes down the screen as far as you want it to. And it can also be scaled, but it can only be made smaller, not bigger, only smaller. And then there's like a tile map that overlays it, everything with 8 by 8 tiles. And that's what's called fixed layer. It cannot scroll, it cannot do anything funny, it just exists. It can only exist. But the real spice, of course, comes from the cartridges. Look at these things, they're ridiculous. They've got 2 rows. They've got 2 boards inside them. That's 2, not just 1. That's kind of like these are huge. And they look like this inside. Actually, these don't, because this is an AES cartridge and this is an MVS port. But ignore that. Look at all these chips inside there. Very spicy. And you can see this can be, there's actually 5 buses on this. Technically 6, but we say 5 buses on this that all access data in parallel to make the game go brr. So there's up to 1 megabyte usually of 68K program. You can get a second megabyte if you abuse the IO range, which they started doing because they needed more space, because 1 megabyte isn't enough. And then they needed even more space, so they added bank switching for the port range. So you can have like 5 megabyte, I think, is the largest one I've saw. Then there's the 80 program, which can be up to 512K, but it's usually just 128K. And in fact, the emulator doesn't handle anything more than 128K. All the games that use more don't work. And there's the fixed tile set, which is for the fixed layer, 128K as well. Can be bank switched. Not sure if any game actually uses that. It is detailed on the wiki how it works, but what's the point of bank switching the fixed layer? I don't know. Then there's the ADPCM ROMs, which actually supply the sound. There can be up to 16 megabytes of those. And then there's the all-important C ROMs, which can have up to 8 megabytes of graphics, or if you're using the extra MSB, up to 128 megabytes. That is a lot if you think about it, right? In fact, there's more that actually fits on the thing. The largest game only actually goes up to 64 megabytes. So it's all good. No, it's still not good, because you still need like a 96 megabyte board to actually hold all, the largest games. We don't have that yet. So we're kind of limited in that. So how do we get it working on the P2? How do we emulate it? Well, we first limit ourselves to only the AES hardware and no memory cards, no extra things, just AES and joystick. On the MVS, you have additional stuff like you have a backup memory, of course, you have the coin-tuned hardware, you have hardware to control the marquee lighting, but you don't really need to care about that because it's just an output. But the backup RAM is the important thing, because it would add 64K more memory, and we don't have that. What we do have is cogs. No, we don't, because they're all used up at 338 megahertz, which is slightly spicy. we have not yet found any that don't work at 338. So I guess it works fine. So Cog0, of course, runs a startup code, but then it actually turns into what they call the memory arbiter. That's basically what interacts with the PS RAM on the P2 edge to actually make it do stuff, such as transfer data. That's what memory does, right? They've got Cog1, this just scans out the video, just boring. Cog2 is what I call the LSPC, because it's sort of does what the LSPC A2 ASIC does in the actual NEO-GEO. And that is figure out which sprites go on one line, and then figure out which graphic they need. So which address in the graphic ROM should be fetched. This sounds simple, but it actually is very complicated. It's partially because there's so many sprites. Then this Cog3 does the actual blitting of the stuff. This also kind of corresponds to the NEO-B1 and ProC0 ASICs, but you can't really say they correspond in any particular way. They just kind of implement the same thing that the hardware does. Cog4 is for the input. The USB driver still only handles one device, so you can not actually play as two-player, which is very stupid because most NEO-GEO games do in fact support two players, and are in fact designed for two players. Then there's the 68000 emulation, which of course runs the main game, the 2610 emulation, which is sound actual synthesis, and the Z80, which is basically just a sound controller. I see someone ask that in the chat. So basically the Z80 just does the sound, which doesn't sound like much, and it really isn't much. It basically just plays the music and makes the sound work. It does a bit of more interesting stuff in some games, where it like tries to figure out which channel has finished playing, so it can like make the sound effects not cut into each other as much. But that's basically the extent of it. I'm really not sure why they thought that was really necessary to have a separate processor for it, but they did. And so we stuck with it. Of course, not just the cogs that are. Someone sent me a message. Oh, obnoxious. Wait, I can just make the edit to do not disturb. Yes. So we only have 512K of RAM, and we need to store quite a lot of things into the hub RAM. So it's kind of packed here. Of course, the first 255 bytes are 0 page. Actually, has anyone other than me ever used like the 0 page on the Propeller? Because you kind of can use it. It kind of has a 0 page, but I've never seen anyone else actually do it. And so use those first, on P1 it's 512 bytes, on P2 it's 256 bytes of directly addressable memory. Not sure why no one does that. Perhaps because the tools don't really do it. Then you get your code and just a bunch of stuff up to FFFF. Then you get the 68000 RAM, which is set as 64K. It has to be aligned like that, because then you can just use set word on the virtual address to get the actual address in the P2 RAM. So that makes it go fast. Then the next thing you get is the pallet RAM, which confusing equation how big it is, but it basically ends up being 32K because there's 2 banks of it for no particular reason. And it's 256 colors, 256 pallets times 16 colors times 4 colors per byte. I always said it was 16-bit. Why is it 32-bit now? I'll get to it later. Then you've got another 64K thing, which is the low VRAM. So that's why it's called low VRAM, because there's also a high VRAM, which is only 4K, and which contains all the per sprite attributes. So these are usually bundled, such that kind of bundled together, so that all the X positions are next to each other, all the Y positions are next to each other, that sort of thing. That's kind of not good, so we shuffle it around in a bit of a way to make everything more adjacent. Then comes the input blob area, where the magic input blob lives, say the USB driver. It has to be a separate blob, to the startup blob because we actually override the startup blob with the Z80 ROM. So we don't have to constantly fetch that from PS-RAM. It would probably be better to actually fetch the Z80 data from PS-RAM as well, because then it wouldn't, then it would actually work with the later games that use the 512K ROM and the earlier games that use the 512K ROM. It's the middle games that use the 128K. I don't know why. And some of the later games don't even have a reason to use the 512K because they at some point stopped actually making the music with the synthesizer. At some point they just started using one big sample per song. It just contains the song compressed and really crunchy. Why do you need 512K ROM then for the Z80? I don't know. They just did it because they could. And also somewhere else there's the fixed layer tile set. And that's basically the entire RAM filled, like all of it, except this last 16K that we.
But did you say you're using the 32 megabytes of the external memory? Yeah,
that too. That's just the hub memory.
Right.
It's all packed in the hub memory, and then the 32 megabyte is also packed full of data. Depending on which game you play, some games are small; they don't need the entire thing. But we do use most of the actual PS-RAM. So we're using once again these scanline graphics pipelining sort of thing. The sort of one cog starts up with starts generating data for a scanline, then another one transforms the data. In NeoYume that was used in a sort of 2 stages, so it was 3 stages. There was a render cog that rendered all the separate layers, and then there was a compositor cog that combined them together. In this case, we don't need any special combining; it just render on top of each other. It works out. But the actual rendering is so complicated that it has to be split across 3 cogs, kind of. The first, as I already said, is the LSPC cog. It scans through the VRAM for the sprites that occur on any given line, and computes the X positions for them and the CROM address that it needs, and then plops it into a buffer of the 96 sprites that can be on the line. Generates that buffer. Then this buffer is sort of passed to the memory arbiter, which, when it's not serving up the data for the 68,000, kind of goes through this list of active sprites and loads the actual graphic data as was requested. And when it's done with that, it makes sure that the ADPCM keeps going. And then the sprite buffer passes to the blitter cog. And that actually just does the rendering in like super unrolled fashion. Let's talk about it. And then it comes to the video cog, which just puts stuff on the monitor, which you'd think is fairly trivial. It can do that in the background, but no, because HDMI hardware is stupid. It has to be force-fed every pixel. Because it has to display them twice because it's 320 wide, but the actual display needs is 480p, so it needs doubled. Well, it's not 480p, it's like actually 800 by 480. A strange LCD resolution that it does. It could do any resolution, but you always have to make huge blankings so it actually comes out to the correct timing. It isn't like weird. Part 4 is the rendering speed hack number 1. As I already said, VRAM is reordered such that all the data for one sprite is next to each other, so we can just slurp it up with 2 RF-longs. That's important because this checking loop that checks if a given sprite is on screen runs 381 times per scan line. And I've optimized it to take 18 cycles per sprite that isn't active. So that still takes like 30% of the time on the line, just to check the sprites that aren't visible. And to actually get to this 18 cycles is a bit hellish. As you can see, the main thing that it's concerned with is this sprite control block 3, which looks like this. It contains the Y position at the top, a sticky bit, and a sprite size. So the sprite size is 16 pixel units, and kind of defines how tall the sprite is. Basically, how many pixels until it stops being active. And the Y position is 9-bit and actually wraps around. So the screen is virtually 512 pixels tall and also 512 pixels wide. We only see 320 by 224 of it, but it's like a 512 by 512 torus sort of because it wraps around. And this check also has to happen with modular arithmetic, such that the wraparound works. And also the sticky bit basically means to ignore all the properties of this particular sprite and just use the ones from the previous one. Or if that one was sticky, that from the previous one. That's so you can stick a bunch of sprites together to make a bigger object and only have to move one around and the others just follow automatically. And so the CPU doesn't have to do as much, but now we have to do it here in the emulator. So the first thing you do is we slurp up all the data. SCB3 ends up in the high half of this TMP1 variable. And the first thing you do is we test for that sticky bit and set it into the Z flag. And if it's not set, then we get our height down here. We get it into the TMP2. Then we left justify it such that it lines up with what the Y position would be. And that means we actually have to shift out the top bit because it goes up to 6 bits. If the top bit is set, then it's always visible because it's taller than the screen actually is tall. So it's basically 32 or 33 tall. The other values don't really mean anything. 32 is just it wraps around the entire screen, and 33 has special meaning, but for this it's the same as 32. We left justified, get that top bit into C. Then we do a subtract. So now in TMP1, we have sort of the line within the sprite that we add. And if it is, then we do the compare here. And of course, if it's taller than, if the position is greater than the height, then we just go back to the top of the loop and start with the next one. That's basically how that works. Oops. And if we got one, then we of course have to reel it in like a fish. Are sprites like fish? Maybe they are. In this case, as you can see, we can just get the Y position from TMP1 because it's in there, but then we can add a CHK line back to TMP1 and get the original SCB2, SCB3 data back into TMP1 because we subtracted it above. This is very big brain. This took quite a bit of time to figure out. Speed hack number 2. Pre-converting the graphics, that's kind of an obvious one. In the actual hardware, CROM is a 32-bit bus, which is made up of banks of 2 16-bit chips, because, I don't know, no one makes 32-bit wide ROMs, I don't think. Well, maybe today, but certainly not in the 90s. And so they're kind of 8-pixel half tiles that they store because it's 4-bit per pixel. So 32-bit can only store 8 pixels, but we actually want the actual quantum of what it can access is logically is 16 pixels, but it only can access 8 pixels at a time. And they're stored in a slightly inconvenient order if you were to just plop it into memory. And of course, because MAME is very funny, they put both of these 16-bit chips that are on the actual cartridge, they dump them to separate files. Because, of course, luckily the CPUs cannot ever touch the graphics ROMs. It is completely oblivious to what's actually going on with that. So you can just convert it into a much more convenient format while we're loading it. That's not really a hack, that's just smart, actually. Speed hack number 3. So when the CPU writes color into the palette RAM, it writes this sort of strange 16-bit format. And by strange, I mean really strange. You can see the top 4 bits of each component are sort of in a nibble. But then there's an extra bottom bit in the top nibble for each channel. And then there's this D thing, which is like a common bottom bit for all the channels, but it's inverted. So if it's 1, it's darker. If it's 0, it's lighter. Why did they do it like this? Because reasons they did it. They just made it happen like that. No one knows what they were doing back in the day. Like this is inconvenient to program with. Why? I don't know. And anyways, obviously we can't use the RGB expand extraction with this. So I have to use some funny code to convert that. But it only happens when the CPU writes it, so it's not that bad. So anytime the blitter cog gets to new sprite or fixed tile, it actually loads 15 of the expanded colors into LUT cells. And I forgot to read this one out. When it converts the colors to true color, it makes it so that the LSB is always set. So black is actually 01, 01, 01. And because it doesn't do bit repeats, white is actually FD, FD, FD. But it looks fine. And repeating the bits wouldn't be terribly useful anyways. It's 6 bits and then bottom one has to be set. You could only repeat 1 bit, no problem. So it loads the 15 colors into the LUT cells 1 through 15. So 0 stays 0 because 0 is a transparent color, right? And then we can take our 64-bit of data it was fetched from the external RAM. It comes in as 2 longs, and we just get nip them into a big array of longs that just contain a single nibble. And then we can adilat into another array that contains all the pixels that we want to write, and then we just burst write all these pixels into the buffer with the WM long. So the hardware does an automatic thing, and the transparency happens in a way that was totally not intended, because obviously the intent with WM long is like 8 BPP and 0 is transparent. But in this case, we're doing it with true color values, which is kind of strange and unusual. But it works apparently. With most of the color conversion settings, the bottom nibble being set is the bottom bit being set doesn't matter anyways, because the multiplication factors aren't big enough to make it actually make it to the DAX. So you don't even see the artifact from it. And the funny bit is that there aren't just these unrolled bits. There's actually a separate unrolled getnip sequence for mirroring. Actually, this is the mirroring sequence, as you might be able to tell. And the other one is the unmirrored one. And then to implement the horizontal sprite scaling, which so you can shrink it from being 16 pixels to being 1 pixel smoothly. And that just works by skipping certain pixels. And the obvious thing is to just have different unrolled sequences for each possible width. And the line buffer isn't just sitting tightly packed in memory. It has actually 16 pixels either side that don't get used. So it doesn't have to worry about cutting off the sprite when it goes off the boundary. It just writes there and it just ends up going to nowhere. But that doesn't matter. So yeah, it is in fact a thing. It can run 38 games. Well, it can run 38 games, but I've added to the database because, as I said, the ROM dumps are slightly funny, and the games have different mappings, how they end up in memory. So it kind of have to go through them one by one and add them into the list. There's 23 ones that work, 3 that would work but are too large, 6 that work but have like broken sound or something, 6 that just don't work at all, and I need to add all the other ones. Its performance is sort of similar to the real machine. It slows down occasionally, but I don't think it slows down quite as much. There's no special features on NeoYume. You actually had some special features. In fact, you could go back to the menu. That's a special feature in my book, because I don't know, it takes work. We can't do it because the menu is gone by the time the game starts. It just doesn't exist in memory anymore. And someone's doing noise. Anyways, yes. Can we mute whoever makes noise? I don't know. Anyways, There's also no, I think NeoYume also had pause feature. Yeah, it had a pause feature. That's nice. You could press the pause button, it would actually hang the CPU until you press it again. That's pretty useful for nothing. But we do have good sound, as I said. It sounds good. It sounds good. Anyways, this is the part you've been all waiting for. I see Chip has slept doing a little bit. I've been looking at his camera, and he has in fact slept for like 5 seconds. So clearly, the boredom is at an all-time high, and it is time for the demo to commence. Let me find where the buttons are. Okay, we've got the line in, but we have to enable this stereo as audio capture, otherwise it won't work. And we have to switch to the video capture input. Which one is it? This one. This is what the menu looks like. You can go up, you can go down. There's games. All the ones that are on the card and also in the database. They have to be in the database and in the card to show up, otherwise they will not show up. So that's quite clean if you actually remove all the games that are boring. And of course we're gonna go with the game that anyone actually cares about. It's the Metal Slug. Very good shoot game. You see how long that takes to load. That's after the SD card optimization for FlexSpin. And
Metal Slug.
we hope that it's actually going through with the capture.
Metal Slug.
But you get the video. That's enough. Actually, we don't
Audio
want
and
to.
video sound good, but and look good.
Mission 1. Start. Heavy machine gun. Thank you. Heavy machine gun. Range. Thank you. Heavy machine gun.
God dang it. Too little the market.
Okay.
What a trap.
Heavy machine gun. Okay.
Note that there's no rotation ability in the hardware. When the tank is going up the slope here, it actually needs different graphics for that. And of course, if it was hardware rotation, it wouldn't look as good. It would look stupid and jaggy. No, they actually have hand-drawn rotation frames, and that's part of why it takes so much memory to actually run this stuff. And you have just witnessed me cheese the boss. Okay, I could have done it properly, but I've just cheesed it because I don't know. I have it in my soul to cheese the boss.
Mission complete.
Because I do not, in fact, am in fact not the epic gamer goddess of mythos. I am in fact
Mission 2.
scrub trash.
Thank you.
Oh man, he's got me. I think I'm just gonna play until his life runs out, which maybe sooner than later. Notice that you can switch the train signal. That's such an unnecessary thing, but you can do it because they had, I don't know, they just did it. You'll notice a lot of unnecessary details in this game like that. That's really cool. Oh, and I just didn't get the rocket launcher. Unbelievable. Ah, there's another one.
Rocket launcher. Okay, thank you. Rocket launcher.
How many rocket launchers are they gonna give me here? Answer a lot of them because I know that they give me a lot. I wanna get that shotgun because the shotgun is good. Come on, get it.
Shotgun.
The shotgun is in fact so powerful that it can blow an entire tank up in one shot.
Thank you.
Look, look, look! Entire tank destroyed with one shotgun.
Heavy machine gun.
Well, that was the life. Let's reboot into something else because we can. And oop, oh, there's a bunch of stuff in the chat. I'll respond to it later. But let's load another game. Let's load Ironclad because Ken put it on the thumbnail and it would be false advertising not to show it. I can show a lot more stuff later if you get to that, but you know, let's just keep the demo short and sweet.
And where are these all loading from?
They're loading from an SD card.
Okay.
In fact, the SD card slot on the P2-Edge. You do in fact not need anything but the P2-Edge and like the breakout boards for like the video and stuff. This might look terrible because it's using all of these 60 FPS flicker effects, and I don't think Zoom video thing is 60 FPS.
Right.
Also notice that this game is weird with languages. The instruction text is in Spanish. The actual dialogue is in English, and then there's random bits of Japanese. Very funny. I don't know why it's like that. I think the Wii version also has that, and the instruction text is in Spanish for some reason. I think that's just like they never properly finished this game. They only actually released it after everything was done on like in fact for the Wii, I think. So I guess they didn't bother to change the default language to English or something. On an MVS you can probably change it to the BIOS, but not on AES. On AES it just gives you Spanish. Like, okay. Oh yeah, the big blue thing. Look, it's like a big demon robot thing. And it shoots little things that shoot lasers. Fucking mental. And then it blows up. But it didn't really blow up. Again, mental.
So, Ada, what are you using for the control device?
I can't hear you over the loud noises. I think I should make it a little bit quieter. I've made it quiet on my end. Actually, I should probably make it even more quieter. What did you say?
What are you using for the game input for this? USB keyboard or something?
In this case, it's actually an official SNK NEO-GEO mini USB thing that I'm using, but it actually works with a keyboard. In fact, it will also work with you just hook buttons to pins. You can do that and it will work. But it doesn't work at the same time as USB.
Ada, someone asked if this audio is part of the HDMI stream, but it's not, right? You're running it as multimedia.
What HDMI stream? This is S-video, mate.
No, but the
That's why it
audio
looks so
part-
crunchy. The audio in this case is analog. If it would have HDMI, no, the audio wouldn't be in the stream. It probably is possible to make it do that, but it would make the brain hurt. And it would also have some issue with sample rate conversion because HDMI only takes like normal sample rates, and this one's at like 53 point something. Or is it 56 point something? 55 point something? Something in that range, something weird and not integer. Basically, it's like some division of the master clock. Anyways, it's now quiet and like you can make noises again.
Well, Ada, have you ever been into a Japanese pachinko parlor?
In fact, I have not. But yeah, that's the sort of the stuff they'd have in a funny arcade.
This is starting to feel like a pachinko parlor. I wonder if we should stop and ask some questions.
Yeah, I'm just gonna finish this level and then we can go to the... Oh yes, explosion. I think the evil train part should come. Yes, the evil train part. Where to say destroy. After we've already destroyed it. Oh no, I said the joke before it's time to say the joke. There we go, that's the evil train. It is in fact very evil, as you can see by the red eye on it. And I am in fact ready, because I know what I'm shooting at. Most of the bosses in this game, we actually can't tell what the fuck they are. Like what is this? It's just a weird thing that floats in midair, and it like looks like metal robot. But this is an evil train, I can get behind that. Of course, each wagon on the evil train has a gun on it. That is the most important thing when you're building an evil train. Maybe someone's gonna build.
More interested in how you did that.
What did you say? I've got it at the lowest possible volume level, and you have to speak up a bit.
Would you rather explain what you're building from them?
Ask it later, I really cannot understand you. Your audio is usually a bit bad, but I can make it... Oh, it goes a bit lower. Say it again.
Okay, there. That's a good time to pause. Let's move to questions too.
I've got 3 more slides or something for
Okay.
4 questions. But first we have to turn off the line in so it doesn't make noises. Okay, and to turn the line in on my pass-through as well. So now I can actually hear you all again. Very cool. I did not play Twin Sprites, even though Ken put it as the biggest one on the thumbnail. False advertising has commenced. But let's switch back to this source that is called Impress shitcap, because it's very stupid how I capture the presentation. That's why it's called shitcap. Yeah, that's the part that Ken asked for specifically. How do you run this at home? Well, you need the P2-EC32MB module and some sort of carrier board. I have the big one.
Ada,
The big. Ah?
question. So you need the 32 megabyte, but the RAM map that you showed was showing the hub memory allocated for different purposes. But the 32 megabyte is needed for what? Is it for buffering larger video?
That's like, no, that's where the game goes into.
Oh, so it's a ROM basically.
Yeah, it's basically using it as ROM.
Okay.
Probably, yeah. Sometimes I start talking and I assume some things. It's good that you asked it.
So that's just serving as ROM.
Yeah.
So
Okay.
your load process then is to load from SD card out to the RAMs and then run the game.
Exactly. That's how it works. So you need VGA, HDMI, S-video, or composite monitor. I'm looking into component. Y'all Yanks probably should like that because a lot of the old CRT TVs in America have the component input. I should probably look into like getting actual RGB input, but that would be more complicated. You need a proper SCART breakout for that because you need to generate all sorts of voltages to make it happy. Can't just adapt it into a thing.
Ada, the video it's actually QVGA, correct?
It's what VGA?
Quarter VGA.
No, the VGA actually gets line doubled up. So it actually scans out each scan line twice.
Is the game actually 320 by 240?
Yeah, the game is 320 by 240, but well, 224 with borders on top and bottom. But when it's scanning it out, it actually scans out each line twice, so it's a standard VGA signal.
Well, I mean, it sounds like this could be made to run on a LCD screen, like one of those.
Yes, you could totally make it. You can make it output anything as long you must make, because everything is timed in relation to the video. You have to make it such that it has the correct timing.
Okay, and I have to go in a second. I just have one quick question. Good job, great work, by the way. But the question was, shoot, I forgot my question. No.
We've got the question slide later.
I'm sorry. Okay, go ahead.
We have the question slide later. You of course need speakers or something. That's pretty obvious. Unless you don't want to hear the audio, in which case you're weird. If you have a cochlear implant, you can actually plug it directly into that and get the sweet, crunchy game sounds directly into your brain. Very cool. You of course need the USB keyboard or one of the particular supported gamepads. General gamepad support is hard, but supporting very particular ones and the generic X input ones, that's easy. That's what it does. Of course, you can also just wire up some buttons that's also an option. Or you can just write your own input driver. It's easy. You of course need the ice ferry. That's very important for cooling. Well, not if you live in like normal place. If you live in the desert, maybe it will overheat. Because there isn't a lot of thermal headroom, you can crash it with a hairdryer. And of course, if you live in literal hell, you're definitely gonna need some sort of cooling. Of course, you need the SD card with the juicy ROMs on it. Juicy. Some you can actually buy on GOG.com. The README file has a bit of instructions on how you do that, because of course they sell it as something you run on the PC, and you just need to copy out the files and it will work on this. But of course the leads don't want you to know this, but just Googling for ROMs is very free. And technically it doesn't even make you go to jail. It makes the person running the website go to jail, but not you, because otherwise you could trick someone and it would be stupid. But it's good for us because we can reload. if you want to. But I have to legally tell you that you shouldn't and are not allowed to. And in fact, unless you're using it for science, in which case free use does in fact allow it. And this is very much scientific. Of course. Use the source. https github.com irksome. Irksome. That's such a silly pun. I love it. That's another slide Ken asked for. Is P2 a good emulation device? The answer is maybe. You kind of get this almost the benefit of what you'd get with like an FPGA device, which is that there's basically no latency between you pressing the button and it's happening on the screen. Well, there is some latency that's kind of built into the game and sort of the hardware of the game. So there's always sort of a bit of latency, but we're talking about the added latency that's added by the emulation. In this case, it's basically the USB input latency, which is somewhere around like 8 milliseconds or something, at 1 to 8 milliseconds, something like that. Really depends on how it lines up. Of course, if you just add raw buttons wired in, then there's no latency. And the video latency is like on the order of microseconds because it buffers lines at a time. And there's of course no audio latency. It doesn't need to buffer anything now. Actually, there may be a single sample of latency if I think about it hard enough. Yeah, there's a single buffer. There's a single sample of latency, but you're not going to notice a single sample of latency, and you're also not going to notice even like 500 microseconds. You're not going to notice as video delay. Whereas if you're running on like a PC or a Raspberry Pi, you get at least 60 milliseconds of video delay because it has to render the entire frame sort of into a bitmap in the memory, and then it has to send that to the video card or whatever, and then it has to wait until the VSync, and then it swaps the picture, and there's at least 60 milliseconds of delay there. And usually it's more because these machines these days, they have so much memory. So usually it ends up being buffered in like 5 different places or something. And you get all this delay. And audio is even worse because you can't really get this sort of matching between audio and video frequencies. So you have to kind of buffer a lot and hope that it never starts crackling when the frequency mismatches. It's very stupid. Even on something that's a little bit more low level, like I've ported a thing to V once. That's kind of got a fixed frequency, but the audio and the video still don't really sync to each other in any meaningful way. So it actually has a little pop every couple existence seconds. So it's stupid how you do audio on modern hardware. Those big PCs, even more embedded devices. Everything's stupid. On P2, you just do it in real time. No latency, no stupid rate mismatch, everything good. But it's of course difficult to program on P2 compared to like on a PC because you have to use funny assembly language. And I say funny assembly language, not just normal assembly language. Funny both in the sense that it's weird, but also in the way that it's quite fun to actually work with. You have these funny things like, I say funny a lot, like the WM long and the LUT and all the other funny things that make certain strange operations go very quick. Skip is also very notable. I think this NeoYume doesn't actually use the skip very much. The C80 emulator uses skip because it can. But on NeoYume, we actually use the skip for, I say we, as if maybe me and the little piggy. Yeah, the pig helps very much. Stupid joke erased the sentence. Yeah, NeoYume uses the skip to do the compositing. And that's like barely possible within the sort of 328 megahertz that it runs at, to actually composite all 320 pixels on one inside the time. And it wouldn't be possible without the skip instruction, or skip F instruction. Yeah, skip F it was. So to see sort of asynchronous nature of each cog doing kind of its own thing, you have this sort of issue that you can't really get everything synced up quite perfectly, especially with the 68000 that doesn't really have a speed limiter on it, because if it had, it wouldn't run fast enough. It really needs to, it's slower at some instructions than the real processor, but some instructions are faster, so you can't speed limit it down because then it would just be slower. But as is, it kind of just goes from being kind of fast enough to being significantly faster depending on what you do. So that alone makes it not really accurate to what the hardware does. It runs the game, but it doesn't really simulate the hardware realistically. That's kind of what the name implies. Yume, dream. It's kind of like punching in a dream. You're punching the hardware, but it's not really there. It's just kind of like a facade that looks a bit like the hardware. It's all in your head. The hardware is in your head. The game thinks it's doing stuff with the hardware, but it's really just punching these paper thin bits of code that do the same thing, kind of. And that's also, upsala. Nein, aufhören. There's also an issue at device boundaries. So what's a device boundary? A device boundary is when there's some sort of interaction between two devices. In NeoYume, there's an example, the sample end register. There's a register that you can read, and it tells you if a particular ADPCM sample has ended. So if it has run out of data and stopped playing. And that resets when you write to it. And I think it also resets when you restart the sample. And that's a device boundary, right? Because if you write to the YM2610 and then immediately check that status, it hasn't had time to update it. So you kind of have to move the tracking of that status partially into the IO register handler, so that it's so that if it clears it and immediately checks it, it doesn't still get the uncleared value. So that's what the device boundary issue is. Once again, the crappy USB driver, only one device per cog. Very stupid. Again, all these games work with 2 players. We can't actually play them with 2 players because you can only plug one controller in. You could do it with the keyboard. You could map the keyboard to multiple joysticks, but come on, you don't want to get your hands in a knot. That's stupid.
Now, is this the limitation of a driver that will get that over time, or?
I don't even know. No one seems to have tried to make a driver that runs in one cog and pulls multiple devices.
Okay.
Another upside to this is that it's highly self-contained. You only really need FlexSpin and its libraries to build the whole emulator. You don't need any funny external dependencies. And it's only a couple thousand lines of code. It's really quite compact in what it does for what it is. And you don't have any sort of headache trying to build it, like you do with a lot of stuff on PC, like where it needs like 50 different libraries and none of them work out of the box. And that's the great issues. I don't know. I always, when I try to build a C project on my computer, I always get a weird depression because, especially if it uses CMake, CMake never works. Just don't use it, please. It makes my brain hurt. So what's in the future? Larger RAM? Question mark. More emulators, maybe, but not now. People seem to be going mad about Amiga, so maybe make an Amiga one. Again, not now, maybe in the future, eventually.
Is the Amiga, does it have quite a bit more complex of chips in it than this thing?
No, the chips on Amiga are like scrub trash compared to what's in NEO-GEO in terms of complexity. But you have to, the big problem is that it has a lot of RAM, not a lot of ROM. So you have to kind of mess. It's really messy with the external memory to do writes to it.
Oh, because you have byte granularity.
Yeah, you have some sort of granularity issue with the. So if you only use a single 4-bit one, that's of course natively byte granular, so you don't have that issue with that. So yeah, thing. I can't think of a name that ends in Yume for that makes sense for Super Nintendo. So I think that's the universe telling me for not to bother. You could do SNES Yume, but that would be stupid. That's not pronounceable in a way any normal human pronounces things. The word super has 5 letters, so it doesn't work because it has to fit in 8 characters. Again, the universe tells me not to bother because that one might actually not fit. Now, SNES is not more advanced than NEO-GEO, you might think, but it's more stupid, significantly more stupid. It's a really stupid design with a lot of features that are only sort of useful, but they all have to exist. And the compositing is very much significantly complicated. It is actually cool. It can do a lot of special effects with like layers and shaped masks and stuff like that, but makes head hurt. Multi-device USB, as said, I'm too lazy to do it because that, I don't know, you have to read the USB spec and that will probably induce deathly depression if you look at the USB spec too much. I should maybe fix these 68,000 bugs because there's at least one. I know it exists somewhere, but I don't know where because it's very subtle. And this is the Panorama Cotton shadow bug that I talked about with NeoYume. There's a game called Panorama Cotton, and there's shadows underneath objects because it's kind of sort of 3D, and the shadows are all at the smallest possible size instead of the correct size. That's the most reproducible bug I have, most easily reproducible, and that one's a nightmare. The other one I have on NeoYume is that Contra Hardcore crashes at the 4th demo. It may actually crash if you just play that level. I haven't actually checked that, but it takes like minutes to get to that demo. So yeah, cool. You have to just let it sit for a couple minutes to crash. Like, very cool bugs that I have. So that's why they're not fixed. And maybe I'm gonna get to work some bit on my own games a bit. No, I have to write stupid things that no one asked for, which my only games actually fall under, but as well. But you know what I mean.
As you've been working with these systems and now you understand the layouts of the different ROMs and things like this so well, does that make it any easier for you to make these games? It's still a whole bunch of asset management, right?
I mean, making games is I mean, I've got the technical part down. Well, it's a bit stupid, and I always realize that something is stupid after I make it. But then I'm stuck with it because I don't want to redo it and redo it and redo it and not get to actually make the game. So I only add to the stuff. I rarely rewrite. That's one way to eventually get done. And actually, the much harder part for me is actually writing stories and scenarios and stuff. That's kind of difficult, isn't it? To make it not mega cringe. Graphics are kind of tricky, and of course, music. Music is very tricky. I mean, you've heard my music. It's kind of okay, but kind of not. Please let me. Anyways, interesting byproducts that have also been produced as part of this endeavor with NeoYume and NeoYume. It's of course the 68,000 emulator core. It's called Motor Core with a K, like Mortal Kombat, because I don't know. It's because I started with MK underscore and then I had to find a backronym for that. That's how that happened. You can't really get it as like a standalone object. You have to copy it out of either of the emulators to make it happen.
Okay.
But I went from copy pasting the I wrote it inside of NeoYume. NeoYume sort of grew from the 68,000 emulator, and for NeoYume I just copied it over and just changed what needed to be changed. Because the memory map is quite more complicated on NEO-GEO. But it's also simpler in some ways because it basically just decodes the top nibble of the address. So you get a bunch of 1 megabyte regions, and one of them is the actual game ROM. That's the bottom 1 megabyte. Then it gives you 1 megabyte of RAM, but it's actually only 64K. It just loops. Then you get the I/O range that most games just use for even more ROM. Then you get something else. Eventually you get the I/O range. Then you get the palette RAM repeated 4 times. So this repeated a lot. And then eventually you get the BIOS ROM, and then you get usually the memory card and like the backup RAM and stuff like that. But we don't have any of that. We don't need any of that. As said, still one mystery bug in the 68000. We have the similarly named because theme Zycore Z80 emulation core. There already was a Z80 emulator, but I don't know, I was too lazy to understand it, so I just wrote my own. That's a good reason to write your own code, is just be too lazy to understand the other one. And I think the other one didn't have the instruction timings, like it didn't have any concept of how long the instructions take to execute on real Z80. The 68000 doesn't have this either, but the Z80 actually needs it in NeoYume, because on Mega Drive there's a very funny way you do PCM samples, which you just get a register that gives you a DAC slot on the YM2612 in that case. And you kind of have to just write at the right speed to make the samples happen. So if the Z80 was too fast, the samples would go too fast, and that would be no good. So there's instruction timing emulation. And for Z80, there's in fact more than, not just one, multiple exhaustive instruction tests. It passes one of them, except for the undocumented flags for block I/O, because they're cursed. It tries, but it doesn't succeed, and I'm too lazy to fix it. Because let's face it, neither the Mega Drive nor the NEO-GEO actually uses any I/O devices. The block I/O would make sense. On the Mega Drive, the I/O in-out instructions just aren't used for anything. It's not connected. And on NEO-GEO, the only thing that's on there are a bunch of weird latches for like bank switching and stuff, and the YM2610, which you cannot write data to very fast, because it kind of, I think it uses some sort of DRAM cell internally, so it only can accept the register write once it gets back around to that register, and then rewrites it with that instead of the old value, something like that. I think that's why you have to wait so long to write. And Maka actually built some stuff with the Z80. Wasn't he here earlier? Is he here? You can maybe say hello. Or not. I'm not your master. Was he earlier? He's there. Just probably has lost his microphone, like I have lost my webcam. I've actually found that it's behind the monitor. But I still don't plug it in as said, because you don't have to see me looking stupid while I talk. Also because the lights are out. We of course have the USB gamepad driver. Oh, that's another Maca thing. I powered him into doing it. I take credit for that. Oh no. And my emulators don't even use the descriptor parsing. They just hardcode certain bit values. And this is a controller that is supported. It should probably use some sort of database sort of table setup instead of just hard coding it, but I don't know, laziness. We also have the amazing shift-gis in FlexSpin. That's very cool. I added that because the GUI for NeoYume needs to show the game names, and they're sometimes encoded in shift-gis, which is ASCII compatible, but sometimes they actually put it in, they actually do use kanji and Senkaku letters and stuff like that. So it does in fact need to render that, and then I decided I wanted to make the strings that I type into the application, wanted to be able to use the white letters as well, so they can, because the narrow normal ASCII letters are barely readable on composite video. So evidently, instead of just typing the byte values in, it was easier to just put it into FlexSpin. The capability to use shift-gis. Extremely useful, not at all stupid. But more seriously, I did in that period contribute a bunch of funny FlexSpinisms. Is Eric still here or is he gone? Oh,
I'm still here, and you did a lot of very useful things. Thank you.
Yes. Again, shift is very useful. Interesting byproducts part 2. The audio here. Of course, you've got the OPN2 cog, so the original one, the YM2612 emulator that was made for NeoYume. You can get it as a standalone object and just make it play tones, funny FM tones, with funny crunch distortion over it, just like the real thing. The YM2612 is kind of a cost-reduced YM2608 with a bunch of features removed, and the original YM2608 needs an external DAC. With the 2612, they actually put the DAC on the chip, but it's extremely terrible quality. But like, it's kind of part of the sound, so actually emulate that. We have a standalone YM2608 object that is not really finished, but it plays. So YM2608 is the original 6-channel FM chip with the Type N operators. I could make a whole presentation on funny FM chips if you wanted, because it's really interesting. But I made this sort of as a byproduct when I made the thing for NeoYume, which is the 2610, because I needed the square wave channels and I needed the ADPCM stuff. So I made a 2608 emulator, sort of as a byproduct. It's not really finished, but it can in fact play the Bad Apple chiptune, which is very important to all. Like the original Bad Apple from Toho 3. No, it was Toho 4. And 3 was Phantasmagoria. Yeah. And of course we have SPC cog, which has nothing to do with any of this. It's the it plays SNES music. I just want to say it again because this is really cool and no one talks about it. It basically runs the sound CPU and the sound DSP in one cog. No sweat. Which is really kind of cool, I think. And no, I'm not writing a Super Nintendo emulator. As I said, shut up. It's not like I like you. Anyways, part 3, Attack of the Duds. You may have heard of the double yolk P2, the mythical being with 9 cogs. But we have in fact discovered the no yolk P2. Oh yes. Pig33 on the forum has one, and it has funny bugs in it. Chip, put your head in shame because you've made bad chip. It bug. It broken. No yolk.
No.
I've simplified it here. It's basically if you do RD long with a pointer, then it sometimes fails. We're not really clear on this. Read the forum thread. It starts at about page 19, the buggy P2 saga.
I think Michael sent an email about this yesterday, and then I forgot. Okay.
Yeah, read the console emulation thread on the forum, start at page 19. A lot of the following discussion is about that. And then you may know the context for the pickled corn. This slide is so deranged. I love it. It looks like something out of a nightmare.
That picture shows honey going onto the pickled corn.
Yes, it does. And that's what it looks like. It corrupts specifically the graphics, because that's apparently the only thing that has the RT long in the particular configuration that it needs to bug out.
Is it using setq?
Nope. I can bring up the code later, but we'll have to get to the question slide because otherwise people will die. Conclusions. We've got the conclusion slide first. Oh no. P2 can do cool shit, except when it's a no yolk unit. If there's no yolk, then we are lost. We are truly lost, and nothing can save us, except the new P2 probably, unless it's another no yolk, in which case I don't know. Just don't. Please write a new USB driver, please. I beg you. I don't want to do it. I want to live. There's a reason for huge memory expansions now, because, as I said, the 32 megabyte is not even enough for all games. I know Metal Slug 2 would work, but it needs at least more memory. More. Too lazy to calculate it right now. But 96 megabytes should be enough for everything. So the first one we get one working. Rayman on the forum apparently is building one for the P2 eval to plug onto. The first one we get one that works, like actually works. I'm not entirely sure on the routing on that one, so I say working. Wins a JPEG of a cookie. It's not on the blockchain or anything, it's just a JPEG of a cookie.
Yeah, I was going to say similar to an NFT.
You just get it sent to your email address. Or I can post it on the forum if you want it. I can. Metal Slug is awesome. We have seen that. Great shoot game. You may have not noticed. I actually haven't shown a single punch game. Like half the games on NEO-GEO are punch games or then there's a couple of step games, and then there's a lot of shoot games. But like half of them is punch game. You just punch. And I have too much free time apparently. That's the final conclusion. Finally, the question slide. Okay.
I have a question.
Work. Good work.
This problem with read long, what forum is it in?
The P2 forum, it's the console emulation thread starting at page 19.
Okay. Starting at page 19.
Yes, you can read the entire thread if you want. It's very funny. But let's go for the chat questions first. The one we don't have yet. Someone said, "What's the killer rep for the NEO-GEO? You've seen it. It's Metal Slug." I guess some people like other games more, but Metal Slug is the one that. Actually, we can look at the illicit ROM site download charts to see what is the most popular NEO-GEO game. Let's do it. Except I can't find it. How distraught. You all shitting me? There we go.
I think what we would need would be something like a separate forum entry for available emulators. I mean, we have by now 3 Z80s, if I can think of.
We need like a list of them. Yes. Anyways, I have to go for the chat, otherwise I will never. There's already new methods at the bottom. How does one even find the technical details for the real hardware? Answer: you go onto the internet and look for them. There's a bunch of websites that contain this sort of stuff, and you just look at them. And that's one part, and the other part is just looking at how like MAME does it. You just look, because you can look at the source code and you can see it how it's done, and then it makes in your brain, and then you can write your own version. Is that technically like a copyright thing and like a license thing? Am I now technically copying MAME? Not really, because I'm not really copying the code verbatim. I'm just copying the logic, and they're just copying it from the real hardware. So brain goes brr. Someone said what the main, I don't know. What P2 hardware is needed to run this? I've said it. Audio part of the HDMI stream? No. How many buttons does the NEO-GEO controller have? It has 4, like 4 face buttons. An A and a B and a C and a D. Well, the actual NEO-GEO controller is a joystick, but I've got the thing here. It also has like a select and a start button. Start button obviously starts the game, and the select button pauses the game. Now, you're thinking, there's never a situation where both starting the game and pausing the game are like pausing the game as in pausing and on pausing. Start only starts the game from the demo or from the continue screen. So why is it like that? Why don't they just make one button? The answer is simple. because on the MVS, the BIOS actually manages the insertion of coins and like deducting the coins from the coins that are in the machine. So it kind of has, so it actually handles the entirety of the start button. The start button, the game shouldn't look at the start button because it's entirely handled by the BIOS. Someone said NeoYume as a possible name for the SNES emulator, but that would be an NES emulator if it was NeoYume. There's no super. Ken went away. Is this an issue for older chips or current ones? The funny pickle issue. The answer is it's a current chip. It's a revision B chip, and it's even the newest revision of the P2-Edge. But it was in fact tested that other current revision P2-Edges do not have the issue, so it just issues on that one particular thing on a one particular cog. Unbelievable. Can I run this with the Parallax HyperRAM add-on board? It could probably, in theory, run it. Slight problem. That only has 8 megabytes of RAM on it, and that's just not enough. That's the whole point, as I said at the beginning, is to make an emulator that actually, well, the point in question, in big quotation marks, the point is that I'm stupid and just build things because I do. But the sort of thing that I put in the presentation is to sort of string you along, is to say that it's to use all the RAM. And in fact, I did make an emulator that uses all of the RAM. Also, that is in fact the P2-Edge that you see Reimu holding there. The one that I have. With DSD card, including the juicy ROMs. Unbelievable, right? So, like how small this SD card is compared to the cartridge. I've showed you the cartridge, right? Perhaps not with perhaps with nothing to scale with it, but these are like huge. I don't even have one because I'm poor, and these are for rich people only. But like they're enormous, actually enormous. And apparently you can fit not just the game, but also all the hardware needed to run it onto a significantly smaller cartridge now. Something about technology, right? And ooh, it's all very, very thing now, very open source.
Where you mentioned that you have one of the controllers. Where did you find that?
You mean on Amazon.de? You will probably find it on your regional variation. They just make it for like their little mini thing. They still make controllers for that. You can also still get Sega controllers, official ones, for USB. But with the NEO-GEO one, you have to kind of take care because it's actually USB-C. So you need an adapter to actually plug it in.
Do you know if I2C game controllers would be good enough for that? Because you could probably get 6 or 8 of them going with one cog.
What kind of I2C controller?
Like the NES. Well, it's what is it?
You know, the V-mode extension style things, yeah.
Yeah,
of course you
can. Controller.
Yep, that's enough buttons. That's enough everything. Not sure how good the D-pad on that is for like making the funny fighting game moves, like the quarter circles and the half circles and the like weird one with the Z. But I don't think that's an issue on everything. I think it's fine. It's in terms of capabilities, it's certainly better than trying to build a controller out of little tact switches. That's that would probably be pain, extreme pain. This is quite nice buttons and bizarre thumbstick thing. You really just need the 4 buttons and the other 2 buttons and the directions. And the directions need to not suck. And yeah, you could totally, the V-mode protocol, you can totally implement that and just make it happen. Not sure what the polling speed is that you can do. I think it's probably infinite. Maybe. I don't know. I haven't tried it yet. I don't think I've ever actually written any code for the V mode controllers, despite having like enormous amounts of them on account of actually owning a V and like using it to play stuff. V is cool, I must say. This is very important. Look, I have V controllers in my hand. You can't see it, but you can hear the shaking of the. That's just the remotes that don't have the extension controllers here. I even have one of these really old ones that need the extra thing for the Motion Plus. And a fake Motion Plus.
Is there any game, any of the NeoYume games that will run a 24 megabyte of PS RAM?
24 megabytes. Yes, we can go to the menu, and then you can kind of see what we're at. Let's switch back to video capture once it's loaded. Yes, having fun with the transition bar. You can kind of see the size next to each game in megabit because it actually needs one more than that for the BIOS and the stuff. But or maybe it doesn't need one more. I forgot how I did the rounding. But as you can see, let's go to Metal Slug. Metal Slug has 210 megabits. That is, in fact, 26 megabytes. No Metal Slug for you. But if you go down to Twinkle Star Sprites, that's 146 megabytes. That would fit. You see the ones that have red in the name, that's ones that don't work. Like if I go to Sengoku 2 right now, that would only be 74 megabit. You can see it boots. I have the audio disabled. Just don't mind.
Yeah, I have one other question. You said you said it's compared well to a Raspberry Pi version. Is that, have you actually seen that? Because I think that'd be an important point.
Yeah, it's more like something like a Mr. FPGA thing in terms of like input latency and stuff like that. And also in terms of hassle, and you see it crashed. That's why it's when the game was listed as red, it crashes 5 seconds into the game. Yeah, it's for the games that it works with, it's better than a Raspberry Pi, certainly. Unless you want like save states on Rewind or something like special features. Those you can only really do on like a big machine. But like just for just playing, this is better. Can Mr. do save states? I don't think so. So yeah, this is about comparable to like a Mr, but probably cheaper if it weren't for the parallax tax. So if someone else built a board with a P2 and like some IO on it, it would probably beat the price of like a Mr. FPGA setup. But it would only be able to run 2 game consoles right now because, and like some of the emulators that Maca built maybe. Because, yeah, you have to write everything from scratch again. Because fun. Let's load Jingle Star Sprites just because you can. Do we have anything else?
Well, it's kind of interesting to see this game was actually, the way I read it, was actually used in arcades too. So you could, it's kind of like people are kind of getting into building their own arcade cabinets at home these days, and it seems like this would be.
That's the thing. As I said at the beginning, NEO-GEO was at first an arcade machine, but then they decided to make a home version that you can buy. But it runs the exact same games. In fact, the exact same games, not the exact same cartridges, because they made them slightly different, so specifically so you can't swap them. But the actual ROMs inside the cartridges, they are exactly the same.
Yeah, but one cog could probably take care of the joystick and actual arcade buttons pretty easily.
Yep, you can just, as I said, you can just hook up buttons. It does work. I don't have a proper controller to use it with that I can connect with just buttons, but I have the amazing parallax button add-on board with the stupid order of buttons, and it works in theory. How many cogs does this take? Someone asked. Oh, Jim Bagley. Cool dude. How many cogs does this take? No, everything's used up. All 8. I've had the slides. Have you not looked at the slides? The slides contain life. That's where the cog map is. We've got all 8 doing something of questionable importance. If you're doing only VGA or something, then you can probably merge the video output into something else. But it would make the code messy, so we don't. I don't think you can merge the 2610 and the Z80. I think that would lead to pain. So those need to be separate. The 68000 definitely needs to be separate. USB input. If you're not using the USB, it probably could be merged. I think even if you did use it with the USB, you could probably merge it with the video output if you really needed a free cog for something. Or if you really wanted, you could just, if you're using buttons, you could just hack the code that deals with the input registers and make that read from the pins directly instead of having another cog just read the pins and put it into a value. That's very inefficient, but it does this because that way the actual emulation code doesn't need to know anything about where the input is coming from.
Do you think
So
the code it does debouncing internally, or do you have to debounce the switch inputs?
No debouncing needed. Well, first off, it only pulls usually at 60 Hertz. You don't need the bouncing at that range, really. Most buttons just don't bounce like that. Most actual gamepad buttons. And if it is an issue, then the game has to do it internally because the real hardware doesn't do anything with that either. It just reads the buttons into the register. Not sure if this on a NEO-GEO, most of the input stuff is actually sort of pre-handled by the BIOS. That may actually be doing something with it. Like it certainly does something related to holding the buttons down. Like it lets you detect that whether the button is just pressed or if you're holding it down. You can of course just compute those manually, but the BIOS does it for you because pretty much everything needs that. So I guess they put it in the BIOS.
So that's it. It's really interesting how you pointed out that Sega Genesis hardware is very similar to the NEO-GEO. It's almost like I didn't see it on Wikipedia, but it sounds like they may have stolen an engineer from Sega to work on this.
Actually, I wouldn't think so. I mean, this was a decently obvious choice at the time. Not sure again why they actually have the Z80 at all instead of having the 68000 just do the sound. They could have probably, if they scrapped the entire Z80 subsystem, they could have probably upgraded to like a 6810 or something. I don't know how expensive things were at the time, but they could probably upgrade the main CPU instead, but they didn't. They made it like this, which I guess has the sort of advantage that the music can run at any tempo, because normally when the main CPU does the music, you're kind of locked into a tempo that's sort of a multiple of the frame rate, versus the Z80, this just gets interrupt from the YM2610 at whatever rate it sets. It gets the timer interrupt, and that usually determines the tempo. I guess that's an advantage. And yeah, compute. There you can see the massive cartridges again. 2 PCBs on top of each other. And they look like this. Can you imagine how expensive these were? Answer, about $200. Yes, it really is that ridiculous. Well, this is a later board. This is a Char256B MVS character board. the earlier ones don't have quite as many ROMs usually. This is fully populated with 8 ROMs.
Yeah, I think so. I think you pointed out, and I think I read it on Wikipedia too. This is like the most advanced arcade home game that was ever made.
Yeah, it was certainly the most expensive home console ever made. It wasn't even the most advanced arcade game when it came out, but it had the sort of cartridge interchangeability thing. That's why it was good, because you could interchange the cartridges. And it, of course, when it came out, when they made it at the AES, it was, of course, destroying all the other home consoles and computers. Well, in some things, you can, because of this sort of architecture where the graphics come directly from ROM, you can't do like any 3D games, like proper polygons. Not possible unless you were to build a special cartridge board that has RAM on it to make it happen, but that would be difficult because the CPU only touches the program board and all the graphics on the character board, so you'd have to have some sort of interconnect between the boards. Very complicated. No one did it. All the games just use normal sprite ROM. So if you want to play like Elite or something, play it on Amiga because it is not on NEO-GEO and it is also not on Mega Drive. They made an NES version which is pretty mental because it has some crazy tile allocation scheme because of the way the hardware works. But it is not on NEO-GEO. Anything else pointless to talk about? Well, I can scroll through the code maybe a bit more to maybe illustrate some of the additional points.
Are you in Germany, by the way? I'm kind of curious. It must be like midnight there.
Yep, it's just around midnight in the land of the big jug beer.
So
I don't know what is Germany known for other than Nazis and beer.
And I think we are transitioning to the open discussion part. So maybe time to end the recording. Any other questions that we need to keep on the record? No? Now we have some people leaving, so let's end the recording.
Yep,
thank you, Ada, for the presentation.
I hope I didn't say anything too stupid on record. Oh, someone asked if I know what my next project is. No, I don't.